All right, guys, are you able to see what is on the screen? Can you all see what is on the screen? Okay. So we are moving forward. I did it purposely by bringing you guys a universal gravitational law problem and also a Newton's law problem so that you can do a lot of practice on Newton's law, because Newton's law can be a bit tricky sometimes. So from our last week's problem, we ended up at this stage. So so what is the next step from here if we are given this equation?
I think we will look for the distance.
You will look at
The distance.
we will make r m the subject of the formula. You agree? I think that's the distance you are talking about. Do you agree?
Yes, I do.
So to make r squared the subject of the formula, what is it that I have to do?
You have to, like, you will say r squared, it is close to 34.
Okay.
0.90
yes,
over
all over
1,3 times 10 to the exponent 8.
1,3 times 10 to the power of 8. And now for those who don't know how she got there, we basically cross multiplied. That's what we did. 1 times r squared m, and then this portion times that one. But that can be correct. If you cross multiply, it will be that portion times 1.3 times 10 to the power of 8, not divided by. This is actually squared. But do you agree?
Yes, I do.
Apex, do you agree? Okay, so what we're gonna end up having is that r squared is given by if you multiply, it will be 5.2, no, 5.76121 times 10 to the power of 20. But remember, that is r squared. So in order to find the value of r, what should I do, Mamsan? struggling to hear you properly. I wonder.
Like, can you hear me now?
What should we do?
Put a square root.
Yeah, that's correct. That's correct. I'm trying to charge my computer. Okay, now that's correct. So from here, we're gonna have, what is the square root of the number that I put in the screen? It will be 2.4 times 10 to the power of 10 meters. So do we all agree? There are other ways you can use. It's just that the question didn't allow us to use, because they said calculate the orbital radius without using the given value of g at A, or the mass of Jupiter that you have calculated. Okay, I wanted us to do question number 2. Question number 2, which is Newton's law. I want you guys to be well vested with Newton's law. Okay, now they said 2 crates, 3 kg and 6 kg respectively are connected with a thin rope. They are pulled up a rough plane with an incline of 30 degrees to the horizontal. A force F is applied parallel to the plane as shown in the diagram, accelerating the system of the crane at 2 meters per second square. That's the acceleration up the slope. The frictional force acting on the 3 kg and 6 kg crates are 10 and 17 respectively. Now, before we move on, what Newton's law comes to your mind? Can we apply Newton's first law? Ronel? And why? Can we apply Newton's first law? Mamson? Can we apply Newton's first law? Can we apply Newton's first law on this one? And why? The answer is we cannot use Newton's first law because Newton's first law talks about constant velocity and objects at rest. And in the question, we have an accelerating system. So if your system is accelerating, we're going to be using Newton's second law. Why? Because there is acceleration. Okay, let's see. 2.1. Draw a fully labeled free body diagram for each crate. Okay, the 3 kg apex. What forces are on the 3 kg crate?
Tension force.
Which one?
Tension force.
Okay, there's tension. What else?
Gravitational force.
Gravitational force. What else? What else?
Friction force.
Frictional force. What else? If you have a surface, forces that should come to your mind are the following: frictional force and normal force. If you have a rope, what must come to your mind is tension force. If you have a mast, what force should come in your mind? Apex.
Gravity.
Force of gravity. Okay, do we have a surface? Do we have a surface? Apex.
Yes.
So if we have a surface, automatically we have these two forces: friction and normal force. Wherever there's the surface, these two forces are there. And whenever there's a rope, there's tension. Wherever there's mass, there's force of gravity. So that's a 3 kg force diagram. And then the 6 kg. Ronel, what forces do we have?
Friction and normal.
Okay. Friction and normal, because we have a surface. Okay, do we have a rope? Do we have a rope attached to our 6 kg mass?
Yes.
Which force is associated with the rope?
Tension.
Tension. What other forces? Do we have a mass?
Yes.
What force is associated with the mass?
Friction.
Friction is associated with the surface and normal force. The mass is associated with gravitational force. You agree?
Yes.
What other force do we have? What force is that one?
Tension.
You can call it tension, but it's force applied. It's force applied. F. We can call it FA or F. Force applied. But are we all in the same page? Then this angle again is 30 degrees. Does anyone have a question on the free body diagram? Ronel?
No, sir.
Mamsal? Do we agree? I just hope we all agree. Okay. So what we will have, we have answered 2.1. Now 2.2, it says calculate the components of weight of each crate parallel to the slope. This is our force of gravity, Fg, and this angle is 30. We have two axes. This axis is the parallel axis to the slope, and this one is the perpendicular axis. Now we have force of gravity. We want to break it down into components. Now apex, what will be the components of gravity in this direction? And the force of gravity component in that direction. First, let's start with this one. Kashiso, what will be the value of this component?
For the force of gravity.
Yes.
As for the, it will be the 3 kg, as I think.
Yeah, but we want to express it as a component. Okay. Do you see what the angle is?
Yes,
The angle is 30 degrees, right?
yes,
And the force that we are determining is the force of gravity. You agree?
yes.
Okay. Which limb or which part of the component forms the angle with the force of gravity? You agree that is this one? These two forces form part of the angle. You agree?
Yes,
So the limb that forms part of the angle, automatically it's a cos. You agree?
yes,
Then the other one should be the sine. Sine of 30 degrees. So these are the two components. Now let us go to the question. The question says, calculate the component of weight of each crate parallel to the slope. Do you agree that this component of gravity is parallel to the slope? Do you agree?
yes, I do.
So if it is parallel to the slope, then the parallel component on a 3 kg, it will be Fg sine of 30, which is mass times gravitational acceleration, sine of 30. What is the mass? 3 kg, you agree?
Yes,
Times 9.8 times sine of 30. The answer is, this will be 14.7. Do you agree?
yes, I do.
And then the parallel component of 6 kg will be Fg sine of 30, which is 6 times 9.8 sine of 30, which is going to be 29.4 newtons. Do you all agree? Are we all on the same page? Okay. Then the next question, for this question I have 4 marks. So if you get each one of them, you will get 2. Now calculate the magnitude of applied force F and the tension T in the rope. Apex, what will be the first step? Calculate the magnitude of applied force F and tension T in the rope. What will be the first step? Ronel,
I still write down the formula.
it will be the first step will be, okay, that's 2.3. Because we are dealing with vectors, you have to choose the directions. Do you agree?
Yes.
Then the second step will be the free body diagrams, which we already have. These are the free body diagrams. Now, what do we do? Ronel, Mansan,
So, so can I guess?
yes,
Does it have anything to do with Newton's second law?
that's correct. It is Newton's second law. So, but how do we apply it?
Um,
Because all the Newton's law questions, we applied almost the same thing throughout. On the previous problems, what did we do from here? We have to resolve in two directions, the parallel and the perpendicular direction. Do you agree? Instead of using x and y, we're going to use parallel and perpendicular direction. Actually, this is how it should be. These are the two directions we're going to be dealing with. So let us resolve forces on the 3 kg in the parallel direction. Mamswan, what will be the first step on the 3 kg? What is it that is positive? What is it that is negative? We are doing one and the same thing that we've been doing throughout. I can't hear. I can't hear you. I wonder what's going on. I think maybe it's the network. But the first thing that we're going to start with is the tension. Tension is positive. Apex, do you agree?
Yeah.
Okay, and then it's going to be tension. What's the other one? Apex.
Friction.
Plus or minus?
Minus.
Minus friction. And then do we have another one? Do we have a tilted force? The tilted force we have is the force of gravity because it's acting at a specific angle. If we are comparing it to our axis, these are our axes, the parallel axis and the perpendicular axis. Force of gravity is out of our planes. That is why it is a tilted force. So because it is a tilted force, they have asked us to find the components. This will be a minus force of gravity sine of 30. This is the parallel component. It is all equals to mass times acceleration or force net. Force net in the parallel direction. So what we will have is that we will have T minus we will have the value of tension will be equals to, if you take friction to the other side, it will be positive. Then plus force of gravity sine of 30 degrees plus mass times acceleration. This will give us what is the value of friction for the 3 kg apex? What is the value of friction?
Isn't it calculate
It is
mass times acceleration?
mass times acceleration is not friction, it is the value of net force. If you check in the question, frictional forces acting on a 3 kg and a 6 kg are 10 newtons and 17 newtons. They are given. You agree?
Yes.
So it will be 10 plus Fg is mg, which is mass times gravitational acceleration, which is 3 times 9.8 sine of 30 plus 3 times, what is the value of acceleration?
2 meters per second squared.
2 meters per second squared, so it's 2. So all this will be equal to, if you use your calculator,
30.7.
30.7 newtons. That's the value of tension. Now what will be the next step? Ronel,
So we have to calculate the tension of the 6 kgs.
that's correct, but how? The tension, you mean the applied force, right?
Yes, yes.
Okay, but how? How are we going to do it? I can't hear properly. But we have to resolve the 6 kg parallel. Which will be Mamswan. How do we resolve the forces on the 6 kg? Khatiso,
I think we start off like first applied,
force applied,
then
which is positive, I agree. Then
after that you're gonna say minus friction,
minus friction,
minus tension,
minus tension.
then after that you're gonna say solidity.
Will it be a minus or a plus?
A little bit a positive.
Why is it positive? Is the component going in the positive direction? Is it going in the positive direction? Is it going in the positive direction?
No,
Therefore,
it will be a minus.
a minus. That's correct. Sine of 30. You agree? And then
Yes. After that,
it will be
we're gonna say minus factor is equal to MA.
that's
Then
correct. Then
after that we're gonna say then we're gonna say first applied,
force applied,
then After that, you're gonna say minus 17.
Minus 17.
Then minus I'm not sure about this one.
Yeah. You're not sure, but we just calculated it most previously.
Then it's gonna be minus 30,7.
30,7.
Then minus 6.
6 times.
9.8.
You forgot 9.8.
Yes.
Okay, so this will be sine 30. And then
You're gonna say
plus.
MA.
Why are we adding MA?
I don't know.
You must have a reason. Why don't you say it's equal to MA? Then M it will be 6 times what is the value of acceleration?
2.
2. Do you agree with all that? So from here, from here,
So then you're gonna say force applied
force applied
is
equals to
17
17
plus
plus
30,7
30.7
plus 6
plus 6 times
times
9.8 sine of 30, ne?
S,
Then
and then it will be
what happens to this? It's Ronald.
Yes, sir.
And what happened to 6 times 2?
You added into the equation.
Yes, it will stay the same because all these terms, if you take them to the other side, they must all get a passport, meaning they must change their signs because they are going to the other side of the equal sign. But this portion is not going anyway, so it will retain its positive. So how much are we gonna get?
89.1 meters.
89.1. That's correct. That's correct. 89.1. Where's my 89.1? What is the units? Newtons, right? Okay, that's not the only way of going about it. You are allowed to combine the mass of the two boxes. You can do so. So if you combine the mass of two boxes, you agree that you will have the normal force. Your new free body diagram will be like this. Then force applied, then your friction with no tension. If you combine the two, you eliminate the tension. So what you will have is that your friction will be 10 plus 17. That's the friction of the two boxes, which is 27. And then your force of gravity will be, the two masses are 3 plus 6 times 9.8. Let's see if this will give us the same answer. So on this one, you will see that force applied minus friction minus Fg sine of 30 is equals to ma. The mass is the mass of the two objects. So let's see what we're going to have. Fa is equals to ma. If you take friction to the other side, it will be positive f. If you take this one to the other side, it will be Fg sine of 30. Now this will be equals to 9 times 2 plus friction is 27 because it's 10 plus 17. 10 plus force of gravity is, if you add 3 plus 6, you will get 9. Is the two mass is mass. Then times mass times gravitational acceleration of 9.8. 9.8 sine of 30. Can I get someone to calculate this one for us to see how much we're gonna get? How much are we gonna get?
The same amount, sir.
89.1 is the same answer. So I used to do all these tricks when I was still in high school, and it used to save me time. But if you think using the first method will be more convenient to you, then you can use it. But this one is, it's a shortcut. This one looks a bit longer, but they all end up in the same answer. So does anyone have a question on Newton's law? Any question? Mom Swani, any question?
No, sir.
Apex,
No, sir.
Khaliso, Khasiso,
No.
Renewa.
No, sir.
Okay, so I'm just gonna repeat these to say, whenever you are dealing with questions of an incline, the method will be the same. If you are dealing with an incline, if that is theta, the gravitational component which is parallel to your slope will always be Fg sine of theta, and the one which is perpendicular to your slope, it will always be Fg cos of theta. Always. If you have to cram it, you can do so. It will always be like that. Whenever there's a slope, even if the slope is facing in that direction, if they say find the components of gravity which are parallel, because that the angle theta will be the same, this angle will be the same as that one. So if you are trying to find the component which is parallel, it will be Fg sine. That's the parallel component. And your perpendicular component, it will be Fg cos of theta. Always. If you have to cram it, do so. I'm glad there's no one with a question, but is there anyone with a question on gravitational law?
Say, I have a question.
Yeah, bro.
Yes, can I ask why the normal force and the gravitational force is not the same thing?
It is not the same thing in this case because we are dealing with forces on an incline. Whenever you put a mass on an incline, force of gravity will always point vertically, because the force of gravity always points towards the center of mass, towards the center of earth, sorry. So the direction of force of gravity is always vertical. However, the normal force is the force of gravity. However, the normal force will always act perpendicular to the surface. The only time when the force of gravity will be equals to the normal force is when your surface is vertical. As you can see, these two forces are on the same axis. Do you agree?
Yes.
But on this situation here, these two forces are not in the same axis. Fg has components. So the only thing that I can agree with you is that in this case, do you agree that the normal force in this case is equals to the gravitational component, not gravitational force? Do you agree?
Yes.
Are you answered?
Yes.
Okay,
Thank you,
so
sir.
no problem. Does anyone have a question from question 1? Inverse square relationships, gravitational acceleration, or the magnitude of the field, of the gravitational field. I think 1.5.2 was a bit difficult. It's one of those questions that you would hardly find in the exams, but it's good to practice it as well. So I think time has run out. Thank you so much for being part of this lesson. We're going to have another lesson next week, Tuesday. We're going to have another lesson next week, Tuesday. So I will start on the new chapter next week. But on the same chapter, I'm also gonna bring few questions from gravitational acceleration so that you get used to it as well. I'm also gonna send you guys a new task on gravitational acceleration, maybe 1 or 2 questions that I can do on Sunday or Monday. Okay, so thank you guys. I'll see you guys next week. Cheers.